Hello, everyone, and welcome to lesson number 4. This is indeed lesson number 4, and we're definitely glad that you are here. Today, in this lesson, we will be looking at geometric sequences. So, lesson 4, geometric sequence. Let's begin. Okay, so what is a geometric sequence? A geometric sequence is a sequence where each term is found by multiplying the previous term by a constant that we call r. So in a geometric sequence, there exists a constant that we call r, and we can take that constant, multiply it by the previous term, and that's going to give us the next term. What else do we know? Well, in a geometric sequence, we have this constant r, but how can we find this constant r? How can we calculate this constant r? Well, the constant r can be found by dividing any term in the sequence by the term before it. So let's consider this sequence. This sequence is indeed a geometric sequence, and we're going to prove that it's a geometric sequence. Notice that we have 2, 6, 18, and 54. First, let's find out what is r. Let's find out what is this constant r. Now, how can we do it? In order for us to do it, we have to take the previous term, which is 2, and take the next term, which is 6, and divide them. So let's divide. So we have 6 divided by 2, and that gives us 3. Now let's do it with 6 and 18. So we divide 18 by 6, and that also gives us 3. Next, let's do 18 and 54. Well, 54 divided by 18 is 3. So that means that the common ratio, that's what we call r, this constant, we call it the common ratio. That means that the common ratio r is 3. And we found that simply by dividing the first term with the second term with the third term with the fourth term, and the list goes on and on. But how can we find this missing term? How can we find this missing term that's here? Remember, it says that it's a sequence where each term is found by multiplying the previous term by a constant that we call r. So what does that mean? In order for us to get 6, we said 2 multiplied by 3, that gives us 6. And then we say 6 multiplied by 3, and that gives us 18. And we said 18 multiplied by 18 multiplied by 3 gives us 54. So in order for us to find the missing term, all we need to do is multiply by 3. So in each case, we multiply by the common ratio. So we say 18. So we say 50. So we say 54 multiplied by 3, and 54 multiplied by 3 is definitely 162. So the next term in the sequence is 162. Next, let's consider the general formula for a geometric sequence. Now, the general formula for a geometric sequence is x sub n, which is equal to a multiplied by r to the power of n minus 1. Now let's go back to our geometric sequence. For our geometric sequence, this value, number 2, is our first term in the sequence, so that's going to be x sub 1. So in this case, n is equal to 1 for x sub 1. Then we have our next term in the sequence, which is x2. That's our second term. And in this case, n is equal to 2 because this is our second term. Next, we have 18, that's x sub 3. That's our third term in the sequence. And in that case, n is equal to 3. Next, we have the fourth term in the sequence, x sub 4. In this case, n is equal to 4 because we're dealing with the fourth term in the sequence. Next, we have x sub 5, or x5, and that is the fifth term in the sequence, hence n is equal to 5. Okay, so now we know what n is in each case. What is a? Well, a is the first term in the sequence, and the first term in the sequence is definitely 2. So let's write that down. A is 2, and A is 2 because A is the first term in the sequence. So A is the first term in the sequence. What is R? Well, R is the common ratio. That's what we found in the previous slide. R is 3. So A is 2, R is 3. And so let's go about trying to find each term in the sequence. So let's begin. X sub 1, that's because we're trying to find the first term, so n is equal to 1. So n is equal to 1, so 1 is here because n is equal to 1. And so wherever we see n, we're going to put 1. So we put 1 here because n is equal to 1. And here, n is here as well, so we're going to put n, so we're going to put 1 here because n is equal to 1. Again, n is equal to 1, we put the 1 here. N is equal to 1, we put the 1 here, just like how we see inside the formula, n is here and n is here. So 1 is here because n is equal to 1, and 1 is here because 1 is because 1, and 1 is here because n is equal to 1. So that's the first thing. Next, we consider 2. 2 is a part of the formula because here, A is 2 because A is the first term in the sequence. So A is 2, so that's good. And then 3 is our common ratio. So we put 3 here. And we always subtract by 1, so that's fine. So we have 2 multiplied by 3 to the power of 1 minus 1. Well, if we consider this, 1 minus 1, now that's 0, right? That's 0. So we're basically dealing with 3 to the power of 0, okay? Now 3 to the power of 0 is 1. 3 to the power of 0 is 1. So that means, so 3 to the power of 0 is 1. So that means that we have 2 multiplied by 1. And 2 multiplied by 1 is just 2. So let's actually do it. So we have 2 multiplied by 3 to the power of 1 minus 1. 1 minus 1. Okay? And that's going to be equal to, it's going to be equal to 2 multiplied by 3 to the power of 1 minus 1 is 0, which is the same thing as 2 multiplied by, remember we said 3 to the power of 0 is 1. So we have 2 times 1, which is definitely 2. And so that's how we get that one now. Next, let's do the next one. Erase that. So what we have here is we have x sub 2. Well, x sub 2, remember for x sub 2, we're trying to find the second term. So n is equal to 2. So if we see n, we're going to put 2. So we put 2 here because n is equal to 2. And we put 2 here because n is equal to 2 as well. Next, we keep 2 constant because that's the first term. And we keep 3 constant because that is the common ratio. So let's go ahead and do it. We have 2 multiplied by 3 to the power of 2 minus 1. What is 2 minus 1? Well, 2 minus 1 is 1. Okay, that's 1. So we have 2 times 3 to the power of 1, which is simply 2 times 3. And 2 times 3 is definitely 6. And so that's why our answer here is 6. And that is indeed x sub 2, our second term. Next, let me erase everything. So let's look at x sub 3. Well, x sub 3, well, in this case, n is equal to 3. So if we see n, we're going to put 3. So we're going to put 3 here because notice in the formula, n is equal to 3. And here we have n as well. So we have n here. So if we see n, we're going to put 3. So 3 and 3. We keep the 2 constant because that's a, that's the first term. And we keep the r constant, that's 3 because that's the common ratio. So we have 2 times 3 to the power of 3 minus 1. So we have 2 times 3 to the power of 3 minus 1. What is 3 minus 1? 3 minus 1 is 2. So what we have here is 2 times 3 squared. What is 3 squared? Well, 3 squared is simply 9. So we have 2 times 9. What is 2 times 9? That's going to be 18. And so that's how we get 18 as well here. Okay, let's move on to the next one. We have n is equal to 4 because we're dealing with the fourth term. So since n is equal to 4 and we're dealing with the fourth term, we have 4 here. So wherever we see n in the formula, we're going to put 4. So n in n. So we're going to put 4 here and 4 here. Good. Remember the 2 stays constant because that's a, that's the first term, and the 3 stays constant, that's the common ratio r. Okay? So we have 2 multiplied by 3 to the power of 4 minus 2. What is 4 minus 2? 4 minus 2 is 3. So we have 2 times 3 to the third power. Okay, so it's going to be 2 times 3 to the third power. What is 3 to the third power? Well, that's 27. 3 to the third power is 27. And we have 2 times 27. 2 times 27 is definitely 54. And that's how we get 54 here. Let's do the last one. Let's do the last one. Now we have n is equal to 5, right? Because we're dealing with x sub 5. And so we have x sub 5, that's going to be 2 multiplied by 3 to the power of 5 minus 1. We have 2 because that stays constant. That's the first term. That's A. We have 3. That's the common ratio R, so that stays constant. We have n is equal to 5. So n is equal to 5. So whenever we see n, we're going to put 5. So we put 5 here. We put 5 here because n is here and n is here. So whenever we see n, we're going to put 5. So we have 2 multiplied by 3 to the power of 5 minus 1. 5 minus 1 is 4. And so we have 2 multiplied by 3 to the power of 4. Now, if we want to do 3 to the power of 4, what we're going to do is we say 3 to the third power multiplied by 3, which is basically 3 to the third power. What is 3 to the third power? We just saw that 3 to the third power is 27. So that's basically 27 multiplied by 3. So 27 multiplied by 3, okay? And what is 27 multiplied by 3? That's definitely 81. So it's going to be 81, all right? So it's going to be 2 multiplied by 3 to the fourth power. You can just put this inside the calculator. That'll give you 81. So this is 81. And it's going to be equal to, what is 2 times 81? Well, 2 times 81 is 162. 162. And so that means that our fifth term, x sub 5 or x5 is definitely equal to 162. And so this is how we can use our general formula for geometric sequences to find each term in the sequence. Hopefully you find this video helpful. I'll see you in the next one. Take care, everyone. Bye-bye, bye-bye.